Okay, so we're looking at a paper. This is November 2018. Checking out the answers. I know that I've given this to my classes this week. It's been given out by a lot of the other maths teachers as well. So let's get straight in there and have a look. So first question we've got here is -3 add -8. Now, I know a lot of people at this point will be going, well, a negative and a negative makes a positive. That rule is true when you're multiplying and dividing, and method's a little bit different when we're adding and subtracting. So when we're adding or subtracting, we should be looking to start where that first number is. So we are starting at -3. The next thing we should be doing is interpreting what we've got in the middle. So we're starting at -3, and then we're actually adding on a -8. When we add a negative on, we can replace adding a negative with simply taking away. So we're going to start with -3, I'm going to take away 8. So if I jump down from -3 by 8, remembering that 0 is somewhere up here, we've got -1, -2. If I jump down by 8, I'm going to end up at -11. Right, question 2. Confused a lot of my students in lesson this. What does the longest bar in a bar chart represent? Well, the longest bar in a bar chart, is it the mean? Does it show me what all the numbers added up together and divided? No, it doesn't make sense. Does it show me the number that's in the middle? Possibly, but not always. Does it show me the most popular number or the most popular thing? You know it does. So the only one which really makes sense there is the mode. Okay, next one says 1.1 minus 0.15. Now some people I've seen just figured this in their head. If you are not blessed with the ability to figure this in your head, when you line these things up, remember that you line them up at the decimal point like that. Maybe fill in a 0 in the space, you've got the same number of decimal places, then we'd say, right, 0 less 5, I cannot do. So I borrow 1 from here, get 10 there, 10 take 5 is 5, 0 take 1, again I can't do, so I borrow 1 from here, get 10, 10 take 1 is 9. The point stays there, 0 take 0 is 0. So we've got 0.95. As I say, a lot of people manage just to figure that in their head, kind of thinking, right, 1.1 take 0.1 is 1, then 1 take 0.05 will be 0.95, and they just figured it that way, which is useful if you can do it. Okay, so here we are on question 4. On a circle, which of the following is always longer than the diameter? Well, the diameter of a circle is the line that goes from edge to edge on the circumference through the middle of the circle. A chord, however, is a line that goes edge to edge, not through the middle, generally. So that will be smaller than the diameter, not longer. It needs to be always longer. Now, an arc on a circle is a line that goes through part of the circumference. So it could be that we have what's called a minor arc, which is less than halfway around the circle, like that. Or it could be that we have a major arc, which goes more than halfway around, like that one. But that means that it could be longer than the diameter, but it could also be shorter. Our question asks us for something that's always longer. So we can't really justify either of those as being always longer, because it could be shorter, could be longer. The radius is the line that goes from the middle to the edge. So that's half the length of the diameter, again smaller. This leaves us with the circumference, which is the distance all the way around the edge, like that. So definitely longer than the diameter. In fact, pi times longer than the diameter. Next question requires we do 83 times 26, just testing us out on our long multiplication here. I'm going to go with the grid method in the traditional way, 80 and 3, 20 and 6. Either way, I refer to it as traditional. Right, so 80 times 20, do 2 times 8 is 16, and then the 0 from the 80, the 0 from the 20 get multiplied on as well. 3 times 2 is 6, and there's a 0 from the 20, but no 0 on the 3. 8 times 6 is 48, then there's a 0 from the 80, and then 6 times 3 is just 18. We've then got 1, 6, 6, 0 in that row. 4, 9, 4. Why have I written 5? 498 in that row. So then we add those together. 0 plus 8 is 8, 6 plus 9 is 15, 6 plus 4 is 10 plus 1 is 11, and then 1 plus 1 is 2. Question 6. Cost of 3 calendars is £18. Work out the cost of 5 calendars. 18 over 3. Woo. Let's try again. 18 divided by 3 is 6. 6 times 5 is 30. Okay, question 7. A helicopter blade does 3,206 full turns in 7 minutes. Work out the number of full turns per minute. So 3,206 divided by 7 using the bus stop method. 7 can't go into 3, so that 3,000 is used as a 10 in the hundreds column, so we've got 7s into 32. Now 4 7s are 28. 28 off 32 is 4. 7s into 40, we've got 5 7s is 35, with 5 left over from the 40. 7s into 56 is 8, so it goes exactly 458 times. Okay, question 8. At a cinema, films are shown on screen 1 and screen 2. Customers pay full price or child price. There are 3 times as many customers in screen 2 as screen 1. 68 customers paid child price. Complete the frequency tree. So we look at the frequency tree. The way it works is that the first box, the first oval, is broken down into those people who went to screen 1, those who went to screen 2. Then the screen 1 people are broken down into those who paid full price, who paid child price, and the screen 2 people are broken into those who paid full price, those who paid child price. So these two numbers here and here should add up to give me this number here. So I can immediately state that we're going to have 72 people in this box, because 72 add 15 is 87. Now, I'm a bit messed up on filling anything else out without looking back to the question. 3 times as many people went to screen 2 as screen 1. So 87 multiplied by 3 is going to give me 7 times 3 is 21, 8 times 3 is 24, plus 2 is 26. So I've got 261 people that went to screen 2. Right, how many? Alright, so I can fill out that box now. So let's say 261 plus 87 gives me 8, 14, and then 2 and the 1 is 3. So 348 people went to the cinema altogether. So in order to fill out this last box, I need to know how many people paid full or child price in screen 2. So I'm going to come up to the one bit of information I've not used yet, that's this, that 68 customers paid the child price. Now, some of my students were tempted to write the number 68 in here at this stage. However, that 68 is customers altogether. We already have 15 child price admissions in screen 1. So that means we must have had 53 customers in screen 2 that paid child price, so that the total number of child prices is 68, because 53 and 15 is 68. Now, 261, 53, the number that's missing to make 261 from 53 is the full price payers. So if we think we need to add 8 to get to 61, and then another 200 to get 208, that's that question all sorted and done. Lots of marks, but if you think through it, not the most horrible question either. So question 9 asks us to work out what fraction is halfway between a half and a quarter, 1 and 1/4, and they've provided us with this number line to help us solve it. So let's have a look at that and think, right, so let's go for 1/4 is there, a half is there, 3/4 is there. So each one of those little dashes is worth 1/4. So we've got 1/4, 2/4, which is a half, 3/4, 1 whole. So this will be 1 and 1/4, and for completeness sake, 1 1/2, 1 3/4. Now the question asks me what is halfway between a half and a quarter. So 1 and 1/4 is there, and a half is there. We're looking at what's halfway between. So we've got 3 gaps, so that's 1 1/2 gaps. The number I need to identify is that one. So the question is, what is that number? Well, in order to do that, I need to go between the fractions again. So I need to think, right, I need to split the whole instead of into fourths, quarters, I need to split it into half of a quarter, which is 8 pieces. So I'm going to have an 8th here, 2 8ths, which is 1/4 there, 3 8ths here, 4 8ths, which is a half there, 5 8ths, which is here, 6 8ths, which is 3/4, and finally 7 8ths, which is in the position I'm interested in. Question 10 ridiculously strange question, this. X is a positive integer. For those that don't know, a positive integer is just a positive whole number. So like 27, 3, 14, all positive integers. It then says 35 divided by x. I know it looks a bit like a plus, but it's 35 divided by x is a positive integer. Work out 4 possible values of x. So it's asking me what numbers I can divide 35 by and still have a whole number. So what whole numbers can I divide 35 by and still have a whole number? Basically it's asking for the factors of 35. 1 and 35 would be the first pair, 5 and 7 the second. A very strange question. I'd be surprised if many people on the foundation paper kind of fully got. Question 11. Fair dice has 6 sides, number 1 to 6. After it's rolled, 5 numbers can be seen. Write down the probability that one of these 5 numbers is 2. So, how many 2s are there on a dice? 1 out of how many numbers we can see? 5. Question part B says, what is the greatest sum of the 5 numbers? So they're saying what of the 5 numbers we can see. So we've rolled a dice. One of the numbers is sitting down on the table. The other 5 we can see. So if we want the greatest possible sum, we want the smallest number on the table. So we've got the numbers 1, 2, 3, 4, 5 and 6. We want the greatest sum. That's the one we don't want to see. So 2 add 3 is 5, add 4 is 9, add 5 is 14, add 6 is 20. Okay, next question. What is 2 sevenths plus 6 sevenths? So when we're adding fractions, the first thing we always want to aim for is the same denominator. Already got it. Good news. So once we've got the same denominator, we should just add the numerators and keep the denominator the same. So we end up with 8 sevenths. So we look up at the answers we've got there, and we can see that 8 sevenths is not an option. Why? Because it's a top-heavy fraction. So what we have to do is we have to say, right, so if I think I've got 8 sevenths, 7 sevenths makes 1 whole 1. So I'm going to use 7 of these 8 sevenths to make 1 whole 1, in which case I've got 1 of the sevenths left. So the answer there is 1 and 1 seventh. Question 13 is a BODMAS question, or BIDMAS question, for those who prefer to state it that way. So we have to remember that that multiplication happens before the addition and subtraction, and equally important, we must also remember that the additions and subtractions, once that's all we've got left, just happen left to right. So what is 4 add 15? 19, take 1 is 18. Right, question 14 says the nth term of a sequence is 5n minus 2. What's the third term? Well, the nth term means that I can put whatever position, in this case 3 for the third term, in as n to work out what the number is. So 5 times 3 is 15, take 2 is 13. Other thing to mention at this stage, we've reached questions 12, 13 and 14. They're the multiple choice elements of the paper, which basically means every question from now on was part of the crossover element between the foundation and higher. So these questions almost certainly appeared on the higher paper too. So here we've got question 15. We'll start with the problem solving now. Trapezium ABCE is made from a parallelogram ABCD and the isosceles triangle where AE is equal to ED or DE. Work out the size of angle AED. So that's this angle they've marked here. I've got to work out what that is. So I can see that the key to working out what that angle is working out what these angles are. Now I'm in luck that these angles are the same because it's an isosceles triangle. But what are those angles? The only information I've got is that this parallelogram here has the angle 110 here. Well, if this is a parallelogram, then I know that the opposite corner angles are equal. So I can say that that's 110 degrees. I would also know that this angle was 70 degrees, but that's not really as useful because the co-interior angles will add up to 180, but that's not so useful. So once I've got the 110 degrees, I can identify that this angle here must be 70 degrees. So now I know that this is 70 degrees, and I know that this is the same, 70 degrees. I can see that I've got 140 degrees in that triangle, and so angle AED must therefore be equal to the missing value to get to 180, which is 40 degrees. Okay, question 16. Ratio where you've got A to B, A to C. How many times bigger than B is B than C? Almost all ratio questions where you've got three elements to the ratio, A to B to C, but you've only got like A to B is 1 to 6, and A to C is 3 to 1. What we're aiming to do is create a single ratio that incorporates all three things. The way to do that is to take the common element and multiply one or both of these ratios up so that you've got the same number. Well, I can multiply 1 by 3 to get 3. So I can say, right, 1 times 3 is 3, 6 times 3 is 18, and then because I've now got 3 in my first ratio, 3 to 18, and we've got 3 here, I can put a 1 there. So it's 3 to 18 to 1. Once I know that the ratio of A to B to C is 3 to 18 to 1, I can just look at the multiplication relationship. How many times bigger is the value of B than C? It's 18 times bigger. Question 17. Laura wants to work out 3% of 1,700. Her method is 1,700 times 0.3. Is her method correct? Now, you're expected to know that to work out a percentage with a decimal multiplier, you have to divide the percentage by 100. So that's 0.03. So 0.03 is what I should be multiplying by. She's multiplied by 0.3, so would actually be working 30%. So her method is not correct. You could say, so should multiply by 0.03. I suppose, or you could say she is finding 30%. Something that suggests you know that she's multiplying by the wrong amount. So Laura also wants to work out 30 29ths of 60. Her answer is 58. Is her answer correct? Give a reason. Well, to work out the answer, what I would do is I'd have to do 60 divided by 29 times by 30. Now, I can't work out 60 divided by 29 in my head because it's going to be 2 and a bit. And so 2 and a bit times 30 would certainly be, well, more than 60 for a start, and her answer is 58. What she has actually done is to do 60 divided by 30 and then times by 29. So, is she correct? No, she's not. Give a reason. Well, maybe I could just suggest calculation should be this. That would be okay. Or the answer, because it's more than 30 29ths is more than one whole, you could maybe just say that the answer should be more than 60. So a couple of ways you can approach that question. A strange one for an uncalculated paper because you can't really figure out the actual answer because dividing 60 by 29 would get pretty ugly pretty quick. Okay, question 18. Here are 5 shapes A to E. In the Venn diagram, the epsilon there is the set of all shapes. Q is the set of quadrilaterals, that's 4-sided shapes. And R is shapes which will always have rotational symmetry. Which means that basically if you rotate them, they will match on themselves before they get back to the beginning. So if we look at that then, so A is a parallelogram. Now a parallelogram has 2 parallel sides like that, 2 parallel sides like that. It is a quadrilateral, and if we rotate it, when we get it upside down, it matches upon itself again, so it has rotational symmetry. And all parallelograms will do that. When you flip them upside down, they match. So we can say that the parallelogram would go in the middle. It is both a quadrilateral and it has rotational symmetry. Okay, B is a regular pentagon. Now, a regular pentagon is a pentagon where all the sides are the same. So if I could draw it accurately, which I haven't, you can rotate it so that it fits on itself 5 times. So it has rotational symmetry, but it's definitely not a quadrilateral because it has 5 sides. So our pentagon, our regular pentagon, goes in there. C is a rhombus. Now a rhombus is effectively a parallelogram where the sides are actually the same length. So it's kind of got symmetry there and symmetry there. All the sides are the same length. But otherwise, in terms of this question, is it four-sided? Yes. If I rotate it, will it fit on itself? Yes. When it's upside down, it will fit on itself again. So we can say that C, our rhombus, is in both groups. D is a scalene triangle. Now, a scalene triangle is a triangle where all the sides are different. Is it four-sided? No. Will it always have rotational symmetry? Well, no, it doesn't have any rotational symmetry. So we can say that the scalene triangle actually sits in the universe. It's in neither of these groups. It is neither four-sided nor does it have rotational symmetry. Finally, we've got the trapezium. Now, a trapezium is simply a quadrilateral with two parallel sides. So we can see that trapezium certainly is a quadrilateral, it's a four-sided shape. However, if we rotate a trapezium round, we're never going to get that scenario where it fits on itself. So a trapezium falls into group Q, but not into group R. Right, question 19. A is 7, B is 2. Work out the value of A over B minus A to the power of B. So wherever there's an A, we put a 7. Wherever there's a B, we put a 2. And we just figure it out. So 7 divided by 2 will be 3.5 or 3.5. 7 squared is 49. So we now need to work out what is 3.5 take away 49. Well, it's going to be a negative number. It's going to be the negative difference of 3.5 and 49. So if I take 3.5 away from 49, because in my head that's easy to do, 49 take away 3 is 6, then take away a half is 5.5. So it's 45.5, but because I'm taking the bigger number, I want the negative difference. So I want to have negative 45.5. Question 20 requires I solve 3x take 18. So I'm just going to go with the classic balancing method. Ooh, this bit of the board doesn't like being written off. Let's try down here. So step 1 will be to add 8 onto both sides of this equation to get 27. So if 3x is 27, divide both of those sides by 3. So we get x is 27 divided by 3, 9. Right, next question, 21. Here are 5 numbered cards. 2 of the 5 cards are picked at random. Work out the probability that the total of the two numbers is more than 30. So I think this is just a listing problem. If I tried to do it by some other method, I think it would get a bit ugly because there's so many different combinations of cards and orders that we could consider. So if we think about the combinations with 23, I could have 23 plus the 17, the 16, the 15, or the 12. So all 4 of those combinations will give me numbers above 30. Now, if we think about the 17, I could have the 17 with the 23, but I've kind of already considered that. I'm just going to consider the unique combinations here. So I've already had 17 with 23, but I could also have it with 16, 15 or 12. Now 17 and 16 and 17 and 15 are more than 30, but 17 and 12 isn't. So I've got 2 that are and 1 that isn't. So next I'm going to move on to 16. What could I combine the 16 with? Well, I could combine the 16 with the 15 or the 16 with the 12. And that would give me 16 and 15 is 31, so that's 1 that is correct. 16 and 12 would be 28, so that's 1 that's incorrect. So I've got 4, 5, 6, 7, 8, 9. And finally, I just need to consider the 15 with the 12, which is obviously too small. There's another one that doesn't work. Now, I should technically be thinking, what about if the cards are picked in the other orders? But all I'm going to get is the same combinations in the other orders. So I'm going to get twice as many combinations, twice as many correct, twice as many incorrect. So it's not going to actually make any difference to the probability, since my numerator and denominator would be simplifiable anyway. So I just want to see how many times is it working. 4, 5, 6, 7. So it works 7 times. out of how many times altogether? So 4, 5, 6, 7, 8, 9, 10 different combinations. Yeah. So if I'd have considered them the other way around, I've had 14 out of 20, which would simplify to 7 out of 10 anyway. Question 22A. So, nasty question to have on a non-calculator paper, having to figure out the squares of negative numbers. So, minus 2 times minus 2. When we do a negative times a negative, we get a positive. So, we just get 2 times 2, which is 4. 1 times 1, which is 1. 0 times 0, which is 0. 1 times 1, which is 1. 2 times 2, which is 4. And now plot these values on the graph. So, we're going to plot 0, 0, 1, 1. 2, 4, minus 1, 1, minus 2, 4. And I've got that lovely kind of parabolic U shape. Then says, use your graph to estimate the value of the square root of 2.6. So how can I use my graph to estimate the value of the square root of 2.6? So the square root of 2.6 is basically saying what number, when I square it, is 2.6. So if we compare that, we can see that we've got x squared wants to output 2.6, basically. So if we look where 2.6 is as the output, the y being the output, we find 2.6 and we need to kind of read across to our graph. So moving down, that's there, and there. So I would say what we've got there, it looks like we've got 1.6 and minus 1.8. So technically they should actually be the same, but so suppose we could say there's 2. Usually with the square root we'd take the positive. But there we go. Question 23. 2 consecutive whole numbers are n and n plus 1. Simplify n minus n plus 1. The fact that these are 2 consecutive whole numbers doesn't really tell me much to this first question. I just need to simplify that n, and then I've got minus n, and then minus 1. So n take n is nothing, take 1 is minus 1. Now, from a mathematical perspective, if I think about that, if 2 consecutive whole numbers, they're talking about like a whole number like 12 and then the next one 13, or 25 and the next whole number 26. And then they're taking the second whole number from the first one. So if we think about 12 take 13, 25 take 26, we do always end up with the result minus 1. Next question just wants me to multiply out, so I need to do n times n and n times 1. The fact that they're consecutive whole numbers doesn't really come into it, other than it being the algebra for those two things. 23 part C, the two numbers are added, show that the answer must be odd number. So this is where the context and the question kind of mix together. So we need to do n plus 1, which is going to be 2n plus 1. So why is it that this is always an odd number? So what I might choose to do is say 2n is an even number, and then add 1 makes an odd number. Question 24, circle the value of cos 30 degrees. So cos 30 degrees is calculated from a half equilateral triangle. Okay, if you know this, you know it. If you don't, it's quite late to be considering exact values. So if we take an equilateral triangle, 60 degrees, 30 degrees up there, because we've split it in two to get a right angle, and we say that this equilateral triangle's sides were 2, 2, and 2, then this right angle is 1 and 2 there. Using Pythagoras to work out this side, I do the square root of 2 squared take 1 squared, which is the square root of 3. So that's there. So the cosine of 30 degrees. We imagine we're in the 30. This is our hypotenuse, this is our opposite, this is our adjacent. Because it's the cap element, it's adjacent over hypotenuse. So adjacent, root 3 over hypotenuse 2. Question 25, work out 8.5 divided by 2 and 2/3, give your answer as a mixed number. So when I want to divide fractions, I need to flip the second and multiply. Before I can multiply fractions though, it's a lot easier if I have them top heavy. So 8.5, well there's 16 halves in 8 plus another one, 17 over 2 for the 8.5. Now 2 and 2/3 is a top heavy fraction, so there's 3 6/3 in the 2 plus another 2 is 8/3. So dividing fractions is easy as pie. Flip that second and multiply. So 17 times 3 is 51. 2 times 8 is 16. So 51 over 16 as a mixed number. So 16, 32, 48. I can get 3 whole ones out of my 51 with 3 left over, which is my remaining 16ths. So I can get 48 16ths to make 3 whole ones, and then I've got 3 16ths left over. Question 26. A ship is sailing in a straight line from its home port. The distance time graph shows 4 hours of the journey. Work out the speed of the ship during these 4 hours. So, distance, speed, time. Dunces, cap, short trousers. So to work out the speed of the ship, I need to do, I cover up the speed, distance divided by time. So how far does this ship travel? Well, if we look here and look here, we can work out how far it was from home port when it started, how far it was when it finished. In order to do that effectively, I need to know how big these squares are. So I've got from 40 to 60 is a difference of 20, divided by the 5 little squares. Each little square is therefore worth 20 divided by 5, 4. So that's 48 kilometres from, or 48 miles from home port. And then 4 squares down from 120 will be 116. So the ship has gone from 116 to 48, or 48 to 116. How far has it travelled? Well, 2 will get me to 50. And then another 50, then another 16, so 52, 68. So it's travelled 68 miles in 4 hours. So we do 68 miles divided by 4 hours. Half of 68 is 34, half of 34 is 17. It is going at 17 miles per hour. Distance divided by time. Okay, 27. Kim works in an airport in the UK. She records the number of planes landing between 10 AM and 2 PM each day. The table shows the data for the first 10 days in January. The airport was affected by fog on one of these days. Which day do you think it was? Give a reason for your answer. So if we look, this one value here appears to be an outlier, 102 planes. So we'll say day 8, far fewer planes than the other days. Okay, Kim uses the data to predict how many planes will land at the airport in a year. In her method, she uses an estimate of 150 planes in each 4-hour period throughout the day, assumes the same number of planes each day, work out her prediction. So we've got 150 planes every 4 hours. So 4, 8, 12, 16, 20, 24. If we guess that the planes run 24 hours a day, that's 1, 2, 3, 4, 5, 6 lots of 150 in a day. So 150 times 6, let's make my life easy here, so let's double it first, is 300, and then times it by 3, that's going to be 900. So 900 planes a day, and we would guess probably 365 days a year. So 365 times 900, which means I need to do 365 times 9. That would be 3,285 planes per year. Right. In fact, fewer planes land in winter than in summer. Fewer planes land at night than during the day. What does this tell us about Kim's prediction? So let's have a look. Kim was looking between 10 a.m. and 2 p.m, definitely in the daytime. So that would suggest that her number of planes is more than during the night. She also looks in January, which is in winter, which would suggest that her number of planes is less than what's in summer. So we may be saying we've got too many planes, but possibly too few planes for summer. So we can't consistently say it's too low or too high, so I would say her prediction could be too high or too low. Give a reason, so we'd say, well, we expect fewer planes at night, but at the same time, more in summer. And so it depends, I suppose, on whether the difference between winter and summer is greater or less than the difference between day and night. But since we've got no information about that, we can't say anything more than we could be either way. It depends on which. There's fewer at night, but also more in the summer. Question 28. The sum of the angles in any quadrilateral is 360 degrees. For example, in a rectangle, 4 times 90 is 360. Zach writes, 5 times 90 is 450 degrees, so the sum of the angles in any pentagon must be 450 degrees. Is he correct? Gut instinct says no. Think about why. So if we try and draw a shape, 90 degrees, 90 degrees, another 90 degrees, how are we going to get 5 sides when we've got everything being 90 degrees? It's not going to happen. So I'm struggling to get 5 sides. You see that 1, 2, 3, 4, 5, 6. Yeah, I'm not getting the 5 sides from a 90-degree shape. So it might be worth stating that. Or if you actually just know, some people might know this, that if you start with a pentagon, you split from a corner to the other corners, you've got these angles going around the edges of the shape here, which are also the angles in the 3 triangles. So 3 times 180 degrees is 540 degrees. There is a formula, the number of sides in the shape, minus 2, then times that by 180. So 5 sides in a pentagon, take 2 is 3, times 180. Tells us there's 540 degrees in a pentagon. But I can't make 4 like 90-degree sides giving me a pentagon. It just doesn't seem to work. Right. Question 29. The square root of 6 squared plus 8 squared is the cube root of 125a cubed. Work out the value of a. Whoosh! Well, isn't that a whole bunch of fun? Okay. So what can we say here? The square root of 6 squared plus 8 squared is equal to the cube root. So 6 squared plus 8 squared is 36 plus 64, which is 100. The square root of 100 is 10. So the cube root, so if I then think, right, what number if I cube root it gives me 10, so 10 cubed is 1,000. So I know that 125 times by the cube of whatever a is has to make me 1,000. So how many 125s make me 1,000? So 125 and 125 is 250, and another 125 is 375, and another 125 is 500. So 4 make 500, 8. 8 to 125 make 1,000. So A cubed must be therefore worth 8, because I need to do 125 times 8 to make 1,000. What number cubed makes 8? Well, it's got to be small, and it's 2, isn't it? 2 times 2 times 2 is 8. So A must have been the number 2. Work out the percentage increase. Question 30. Work out the percentage increase from 80 to 280. So the original value is 80. The increased value is 280. So the change is 200. It's adding 200 on. So to work out a percentage change, I do change divided by original, and then change that decimal into a percentage by timesing by 100. So let's see, 200 divided by 80 is the same answer as 20 divided by 8, which is the same answer as 10 divided by 4, which is 2.5. So then 2.5 times 100 is 250. So we've got a 250% increase. So it's increased it by double and half again. 80 plus 80 is 160. Oh no, it's 250% increase. So it's added 80 and added 80 again. So 80 times 3 is 200 times 3 is 240. Plus half again is 280. Yes, that's correct. Oof. Making my brain work. I like it. Question 31, you have to solve the quadratic. Now, to solve the quadratic like this, we would need to factorise it. That's the only way you solve quadratics in Foundation. So when we're solving the quadratic, we need two numbers that times to make the end value and adds to make the middle. So we're looking for a pair of numbers that multiplies to make minus 12 and adds to make negative 1, negative 1x. Now, when I work with this kind of problem, if I'm multiplying to make a negative, I just think, right, I want two numbers that times to make 12, but then because when I add a positive and a negative, because I need a positive and a negative to multiply to give me a negative, when I add a positive and a negative, I actually end up with the difference rather than the total. So I'm looking for two numbers that multiply to make 12 and have a difference of 1. So the numbers that fit the bill are 4 and 3 for me. Now, all I need to do now is decide where the minus needs to go, because one of these needs to be a minus, so that when I add them, I get minus 1. So if I do minus 4 plus 3, I get minus 1. And that tells me that in my brackets, when I factorise my quadratic, I want to have x minus 4 times x plus 3 equals 0. Once we've got it into brackets, we need to work out what values of x make each bracket equal to 0. So I want x minus 4 to be equal to 0, or x plus 3 to be equal to 0. So if x minus 4 is equal to 0, x take away 4, what number take 4 makes 0? That will be 4. And then what number, if I add 3 onto it, makes 0? That will be negative 3. So a little check just on these. 4 squared is 16. Take away 4, take away 12. That is 0, yes. Minus 3 squared is plus 9, minus minus 3, minus 12. So when a minus and minus I add on, 9 plus 3 is 12, take 12 is 0, yeah. So that's my solutions. X is 4, X is minus 3. That, my friends, is the end of that exam paper. Thank you very much.